Hi people, sorry for the long wait for this update. It's been a few months and the reason behind it's a little bit life got in the way, but also I kind of suspected that Unreal Engine would change a few things in Control Rig, and as we're gonna see, it happened for the better. Now what this means is that Unreal Engine 5, as you probably know, came out as a preview 1 and a lot of stuff has changed, but we're gonna of course focus more about Control Rig stuff. If you scroll down here on the page under animation, you can see that a lot of stuff has changed. They added dynamic hierarchy, which implements some sort of idea that comes from Anzovin. We're gonna see that in a minute. But a lot of nodes have been added, a lot of nodes have been renamed, and this video it's only about what I found out of the box. It's not gonna go in any details. So what I want to say is that yes, some if not most of the nodes that I've been using so far through the course may have been renamed. Things will look different. But what I can see from the few tests I've made is that everything is much simpler. And we will see that Control Rig will come with pre-made functions that encapsulates a lot of the functionality I've discussed in the previous videos. So from a learning perspective, I can tell that the videos that I've made so far are still relevant in terms of concept, but the implementation might look different, if not simpler. And we're going to look at that. I haven't played with it much, but I played enough just to see the biggest differences. So from here, if you click, we have a nice documentation page, and this implements an FK chain, an IK chain, goes through some changes. But one of the biggest ones is actually in the forums and the introduction of a dynamic hierarchy. The idea that you can at runtime change the hierarchy dynamically gives us so much flexibility. It's some kind of a dream to have this, and this basically will impact a lot the way a standard rigger used to think about things and how to solve problems. And the inspiration comes from the ephemeral rig presented by Anzovin, which is a slightly different way to approach the problem of rigging, or how to create structure and hierarchies to make a rig animatable and friendly to animate without complicating the structure too much. Because nowadays in any DCC application we can complicate the structure and hierarchy in the graph so much in order to provide very simple manipulation for the animation to animate. Ideally we would have a much simpler way with a stronger foundation. The rigger can make graphs that are much more simple and easy to maintain. Anyway, we're gonna have a look at this in the course of the next few videos. On top of that, I want to say I'm still learning. The whole idea behind the series is just for us to learn together. So please feel free to tell me that I'm completely 100% wrong in the things I'm saying in this video. Don't hesitate. So let's jump into Unreal. So I have created this is an empty project. I only added the resource of a third person template, and I right click on mannequin female and I said create control rig, and this is the UI I got. This is the new editor. First and foremost, there have been few differences, in visuals, meaning that the buttons look like different. It's a little bit more organized. Absolutely fantastic. I love it. Even if this new, just by the way, this new control rig does destroy a little bit the work I've done in the past, but I love it. This is the development cycle. I'm 100% happy about this happening. So, and you should be too, to be honest, because what they're giving us, it's mental, it's bananas. So, okay, first and foremost, let's start with one thing that I'm really pleased with. When I right click here, you have the option to create a new bone, a new control, and a new null. So this, to me, the naming convention that they're using here basically makes much more sense to me, because these are structures that I'm familiar with. You have a bone, you have a control, and you have a null. Previously you have a bone, a virtual bone, a control, a space, and yes, although they're doing the same thing, the naming here, it's a little bit more in line with what other applications are used to, because some people might get confused with what a bone is or what a virtual bone is. But in this moment, once you have the skeleton, you now know that you can add a bone, that it will behave in the graph as a bone. You can add a control, or you can add a null. A null used to be, I think, what the space was, but basically this will behave as a transform, and you can parent stuff underneath. It's basically a matrix that will behave like a matrix in space. So really, really happy about this. Then the other thing I've noticed immediately, and this is although I don't know if this is because of Control Rig or because of Unreal 5, but Control W to duplicate a node doesn't work anymore. Is now in line with pretty much every other software. To duplicate a node is Control D. And I found that really, really nice. It took a while for me to get used to it, because I was so used to do Control W, but Control D makes sense to duplicate things. This is the other thing I wanted to talk about. Now, let's jump onto something that I consider, extremely well. I'm really happy about. Let's get rid. So in this is my test. Skeleton. I created a control rig, create a few controls here just to see what's going on. We still have the basic stuff, such as the main events are still there. So you still have setup event, forward solve, backward solve, and they're meant to behave exactly in the same way. But one of the first thing that you may notice when you have the list is that the list is now gigantic. You have a lot of stuff in here that we didn't have before. Another thing that you may notice is that now controls, or nodes, in this case functions, they are commented, meaning that it tells you exactly what each attribute does. Prior to that, it was a little bit hit and miss, and you just had to play with attributes to understand what they were doing. Now, the biggest difference is that I found is that not only we are provided with nodes, but you see now we have functions, embedded function or atomic function that are a specific implementation or combination of these nodes. And what I believe this function do is encapsulate functions. This is a compound function that makes things easier. For example, let's have a look. Colorize. You see the icon is different. Where is it? The icon is different. It has a function. It comes from a standard function library. And what I believe this is doing is exactly what I was doing in the graph a few lessons ago. You can pass the controls, and depending on the string, if it's center, left, or right, it will apply a different color. And you can also say ignore controls. So this is amazing. But you can see that when I was doing this with like 5-6 nodes, now you have a single function. Or, for example, hide controls, same idea. You can plug a bit of controls and an array of controls, and there is a boolean that you can trigger on off. Again, prior to this was you have to go loop through the controls, create the array, and for each item set the visibility based on a boolean. But this is a compound function. So what I suspect that these functions are there to simplify the graph visually, because this functions comes as pre-made. I have no idea if we can make this function on our own and put them in the standard function library, but I don't see why not, to be honest. The functionality is there. I don't know yet if it's exposed or not. Let's have a look. Yeah, we have mirror controls, a runtime, or a better, a setup time. During the setup event, once we place the controls on one side, rather than initializing all the controls left and right with their own rule, you can set up only one side and then initialize the position of the other controls just by using this mirror control. So you can see that instead of having 5 nodes for the left side and 5 nodes for the right side, you can only have 5 nodes for the left side, and then boom, use mirror control. And again, when you hover over the function, it tells you what is what. I found this extremely helpful. What else? This, if you go back to my videos, there are different functions that I've made in order to apply this. And this says, use the dynamic hierarchy system to make a control live in IK mode or FK mode. It will maintain its position and not pop on the switch. So the fact that they are giving this to us makes me really happy. But if you want to understand a little bit what's going on, it's basically, you can go back to the previous videos. But this implementation is probably completely different from what I've made, because they're saying that they're leveraging the new dynamic hierarchy system, which is something we didn't have in Unreal Engine 5, the alpha version. So I can't wait to test this out. Again, this video, I'm not going to do much. I'm just going through the bits and bobs that I found extremely interesting. Now, let's have a look at this new node. This is amazing, because it says, you know, this is a better way probably to get automatic documentation once you're done with the graph or the connection of nodes. Here's the dynamic hierarchy. So I haven't played with this at all yet, but I can't wait to try it out. Chain dynamics, there is a new function, but the biggest one to me is the hierarchy. Under hierarchy, so when we implemented functions such as aim, you know, I would call those functions solvers. If you go back, every time I was referring to a solver, I created a function specifically that behaves in a certain way and provides you a specific type of kinematics. For example, the FK solver, you know, a chain of joints driven by a chain of controls, or an IK solver, it's, you know, three bones driven by 3 controls with a pole vector, or an aim. But what you have here now is that they're giving us those solvers as function. So you can see that you can still implement, where is it? You can still implement the aim yourself with all the nodes I've used in the past, but you have additional function that makes everything so much simpler. For example, the FK chain. If I look at the inputs, this looks really similar to what I was thinking when I was building stuff. You pass a set of bones, you pass a set of controls, and then you have additional option for filtering out different channels. But overall, this looks like extremely handy, because you can rig a finger with 2 nodes. You can have a collection of bones, a collection of controls, and that's it. What else? Hierarchy, aim at. And again, when you hover it, you can say arguments, object to aim, target to aim at. This is very simple to use and not much. You know, there is not much more that you need to do basically if you want to have a very basic look at or aim a behavior. Now, one thing I've noticed, and this is really cool, is that some of these nodes now have some outputs, and I'm pretty sure we're going to use this one option a lot in the future. It's not just an execution stack where it computes, but it also outputs the result matrix, which is something you can play with. Again, let's try find closest bone. This is a really good one. It finds the closest bone to the item by distance. So I can see this being used in a setup event where you're trying to make your control pop in the right place automagically based on certain rules, and one of these rules can totally be find the closest bone along this chain. So you may have, for example, a control that snaps to a chain that is 17 bones or 16 bones, but then you want to really rather than using the last bone in the chain, you want to use something that is like a distance, and this node will provide you with that. Let's see, hierarchy, where is it? You can have get transform IK to bone. So this basically it's a wrapper for the solver that they have, which is basic IK. You can see that, you know, this is the node and this is the function, but this function it's probably allows you to encapsulate. It's probably easier to use this one because it includes some debugging options, and let me show you that, what I mean. For example, if I remember correctly, I left this with an IK attached. Yes. So you can see that this is a simple somewhere along the way. I'm not going to explain what I've done here, but basically in the forward solve, I'm simply saying I have my bones specified here, my controls, the up vector, sorry, the pull vector, blah blah blah. So basically with these two nodes I'm achieving this behavior here. You can see that the pull vector, for example, already automatically draws a line where it's supposed to be. And this is something that comes within this node. It didn't come with the, where is it? With the basic IK. This is something I had to implement. If you remember in the previous videos, I had to implement on my own. You have to draw a line between the 2 points in order to make sure that you have a nice line between the two things. So you can see that these are very convenient functions. What else? They are giving us a 3-bone IK, and they're also giving us a piston. And the piston, basically, it's a smarter implementation of an aim, if I'm not mistaken. This is my just guess, but an aim allows you to drive the rotation of a joint or a transform, to be more precise, based on the translation of another transform. So you're basically conceptually converting rotation to translation. You're computing rotation based on translation, which is nothing else than IK if you think about it. IK computes a rotation of joints based on the position of other joints. The piston probably it's something similar, but it should give you the ability to be kind of bidirectional. So if you have a joint here and a joint here, and when you move this aims, this aims, and when you do the opposite, it aims to one another. Let's see what it says. Two-way aim constraint that mimics a piston. Yes. So imagine that you have this joint here, and this one transform, another transform. You move this rotates with it, but when you move this rotates with it as well. So what you get, it's a really nice piston behavior, and it has a debug draw. I haven't tried that yet. So let's see what else. Snap transform. Snap transform probably is a get set the target transform to the source transform. This is a nice way to snap the transform. This is cool, and it outputs the transform as well. I mean, you could do something similar with a get it set, but you may want to use this rather than get it set. You can use that in the event graph, but probably snap transform, it's easier to use at runtime. So if you want to snap two targets together at runtime based on whatever control you're moving, you can say boom, snap transform. I love this. And twist bones. Oh, there is a function for twist bones. Oh wow, I love this. So twist bones, let me see, sorry about my dogs are snoring. You can specify the input bones, the bones that you want to twist at the start and the end, and then probably depending on the hierarchy and twisting. So if they're children of something that rotates, this thing probably will interpolate. So this, again, we call this twist solver. So you can see that, and I don't know, probably this has a quaternion implementation. I have no idea. I need to try. Maybe this avoids completely, the 180 flipping problem. It's a typical problem of Euler. Fantastic. So it means that basically the functionality of the rigs that we looked in the past will still be there, but the graph will look so much simpler. And this is absolutely fantastic. Let's see. Snap transform, twist bone, piston. What do we have here? Splines. Oh. Attach chain to spline. So, okay, this looks like a spline solver. Spline IK, basically. Spline from items. Create a spline from the input item. Ooh, we're not restricted anymore to 4. Yes, I can add things. Oh, they implemented the different implementation of Spline. This is really good. Spline IK. Spline variable spline rig for spline tape. Oh god. Wait, okay, so this is a solver. This is a solver. And it outputs the spline. Okay, so this we're gonna focus a lot on this. So basically, I think what this does, it does the very complex setup and graph that I made for the spline much simpler. You can plug controls and you can plug bones, and it computes the spline internally probably. But what I'm really happy about is that it outputs the actual generated spline, which should make things such as computing the backwards solving of the spline, which has always been an issue, much simpler by probably combining some of these nodes. Set spline points. This is excellent. Another thing I've noticed, sorry, I'm blown away by this stuff. This is gonna make things so much simpler. Another thing that I've noticed, and it's finally, you can promote a pin to variable. This is something I missed a lot, and it looks like, you know, you can do it for pretty much any type, because prior to that, you had to kind of guess what this was, but now you know that it has Spline type. I mean, it was in Unreal 5, but I mean, it looks like this is now fully consolidated. Also, the overall feel, even the look of the nodes, it feels like a blueprint graph, so it's a little bit more consistent. That's how I feel about it. Let's see, transforms. And I have set getter and setters. That's fine. Variables. Oh, these are my variables. Simulation looks like, you know, all the stuff that were in there. Yeah, the overlay. Harmonics, accumulation, yeah, math. Oh, there it is. Okay, so amazing. Okay, love it. Offset factor, brilliant. Okay, so this looks to me like the function or the solver. Probably it's a much better way, but if you remember, when in my IK solver, there is a portion of the graph where I'm just doing some very basic linear algebra, where I'm subtracting the final vector with the first vector, getting this length, then I'm projecting the vector, taking the length, taking the distance, the vector that is the distance between this point and this point, and then basically scaling that by -1 and adding a certain distance that will be my offset. So the idea behind that is that it would place the pole vector in the right place based on the whatever angle you give. It looks like this function does that. Oh my god, I'm super happy. This is gonna take away like 15 nodes, because you know the graph for the computation is very simple. It's just subtraction, projection, scale, and addition of vectors, but it's nevertheless it's like 15 nodes or something like that, and now you have one node, and probably they want you to do that in the setup event. Best use in setup, yes. It says in the setup event, this is where you would. I wonder if they're using this function in the IKFK matching. And it outputs the transform that it computes. So this is really nice. The fact that few nodes are outputting whatever they're computing allows for a lot of flexibility. Yeah, I'm still blown away by the spline stuff, but sorry. Let me see. I'm trying to look. I think this is it for this video. I'm sorry. I just want to say thank you for Epic Games. This looks amazing, and I'm sorry that you will find out that most of the nodes that we did in the past, they are not named the same, or but the reason is, like, you know, this is a development stage. You know, control rig has been improved massively in Unreal Engine 5, so I would suggest not to feel frustrated, but rather very happy, because once you get the concept down of rigging, they never change. The things just get simpler. So this is my, you know, end of video suggestion. Thank you so much for watching.